asks us to use graphing software to graph the following functions, and then we're going to estimate the values of x where the graph is increasing and decreasing. So in the meantime, I just typed Desmos into Google and I clicked on Desmos and it popped up. So we're going to take a look at that. Okay, so let's start with the function x cubed plus 3x squared minus 2. Here we go. Okay, so this is what Desmos looks like. You don't even have to download it. You can just use it straight online. X cubed plus 3x squared minus 2. What does that look like? All right, here we go. So when we take a look at this and we want to look at intervals of increasing and decreasing. So I look at, remember we're reading from the very left. So I look from negative infinity all the way to -2, we're increasing. -2 to 0. Let me write that down. 2 to 0, we're decreasing, and from 0 to infinity, we're increasing again. So what we can do here is we can just write down our solution, okay? So where's the graph increasing and decreasing? So increasing, and then we have decreasing. Okay, we're increasing from negative infinity to 2. I think it was -2. And then we're increasing again from 0 to infinity. And we're decreasing on 2 to 0. Okay, and right at 0 we're not decreasing because our tangent or our velocity equals 0. So if you recall, for the increasing, we know that our tangent is going to be positive, or f prime at x is going to be greater than 0, and for our decreasing, our tangent is going to be negative, or f prime at x is less than 0. Okay, so for those values, we want to put these open rounded brackets, not the box brackets, because we don't actually include -2 or 0. Okay, now let's try the second one. So we have x over x squared plus 1. Okay, so we can x this, and we have x over x squared plus 1. That's it. We're good. So if we zoom out, we can see that as x approaches negative infinity, the y approaches 0. Okay, so we go from 0 and we go down and down and down until we reach maybe this number, -1.5. Okay, so we're actually decreasing until x equals -1. So we're going to decrease on negative infinity to -1. Then we're increasing from -1 to 1. And then we're going to decrease again. And again, we're going to continuously decrease because we're approaching this asymptote. Okay, so on 1 to infinity. We're going to decrease again. Okay, remember we read from left to right. And we can, if we were to draw tangent lines here, they would all be negative. And then tangent lines for this middle portion would all be positive. Again, negative meaning it's decreasing, positive meaning it's increasing. And then on this, from 1 to infinity, again, our tangents would be negative. So let's go back here, and we can write, so it's increasing from -1 to 1, and is decreasing on negative infinity to -1, and then again on 1 to infinity. Okay, I just blew up that that picture right there. Okay, so consider the graph f at x. So we're given the graph f prime at x. We need to graph the original, which was f at x. Okay, so one thing that we have to remember is that when f prime at x is positive, so when f prime at x is greater than 0, our graph is increasing. Okay, and when f prime at x is less than 0, our graph is decreasing. So in other words, from this point all the way to this point, this is when f prime at x is greater than 0. So we're going to have an increase here, okay? And this, and also on between 3 to infinity. So we're going to be increasing on 3 to infinity. We're also going to be increasing between negative infinity to negative 0.5, negative infinity to negative 0.5. Okay, we're going to be decreasing, let's change the color here. We're going to be decreasing when f prime at x is less than 0. So we're going to be decreasing on negative 0.5 to 3. What this means is that these 2 points here, negative 0.5, comma 0 and 3 comma 0, is these are going to be the turnaround points. So this is going to be when the graph of f at x, like our original, goes from increasing to decreasing, and then again from decreasing to increasing. So let's do our best with the information that we're given. There's going to be more than one possible graph here. So okay, so we know that there's going to be a turnaround point at negative 0.5. So let's make that turnaround point. And there's going to be a turnaround point at 3. So let's make that turnaround point. Okay, and we know that it's going to be increasing until then, decreasing, and then increasing again at that number. And we can line these up. Okay, so this is one possible graph of f at x. Just using the information about increasing and decreasing.